Hi, welcome to N7.6. This is adding and subtracting integers. So integers are the negatives and positive numbers that we've been using. And you learned about those last year and we're able to put them in order. Now we're actually adding and subtracting them. So you can do this concretely through a picture or through math symbols. Okay, indicators say you have to represent opposite integers. So -3 would be opposite +3. And to show that concretely, like with algae tiles or objects, draw a picture of it or use math symbols and explain why they're called opposite integers. And I can tell you right now, it's because they are the same distance from 0 on the number line. So if we have -3 down here, we have +3 up here, and that means they're exactly the same distance away from the origin or the 0 on the number line. Explain integer tiles, so we were just talking about those algae tiles or diagrams. The sum of opposite integers is 0. So if we have 3 negatives plus 3 positives, we end up with that 0. There's no net change in position. Illustrate using a number line the result of adding or subtracting negative and positive integers. Adding two integers using some object or some picture. Record the process with math symbols using your pluses and your minuses. Subtracting integers using concrete integers, same thing. Investigate patterns in adding and subtracting integers to generate personal strategies for adding and subtracting integers. So there's a few patterns and rules that we've got coming up that will help you with this process. And then, of course, problem solving. Okay, here are the rules. Adding positive integers yields another positive integer. So that just means if I'm adding a positive plus a positive, that means that I have, let's say these yellow tiles represent positives. So I've got 2 yellows here plus 2 more or 3 more yellows here. So altogether I would have 5 yellows, and we've said that yellow is representing positive numbers. So these are those algae tiles that I was talking about, and I have some of those in the classroom if you want to check them out. Okay, now if the red ones are representing negative numbers, I have 1 negative here, or -1, and I have 2 more negatives here, or -2. The total of my negatives is, there are 3 of them, so 3 red tiles. And so using math symbolically, we would just use this equation. Using it pictorially, as a picture, we would use the algae tiles. So just one last example at the bottom. If I start with -3, and so I have 3 red ones. Oh, I should maybe use red, hey? Oh, yeah. Look at that. Okay, there's a red one, there's another red one, and there's another red one. And I'm going to add one of these, a +1. And then we can go through and cancel out anything that one of each sort of a deal. Okay, and what I'm left with is these 2 red ones. And so the red ones are representing a negative number, so my answer is -2. So that, my friends, is how you use the algae tiles. So when you draw out how many negatives you have, and then draw out how many positives you have, and then you just go through and cross off the guys that 1 and 1. Alrighty, using a number line. So we call 0 the origin, and it's right in the center. And anything going to the right is positive numbers. Anything going to the left is negative numbers. Okay, and here's the key down here. The more you practice, the better you get. There is no real science to integers. It just takes practice, recognizing what to do with your signs and practice jumping around on the number line. So when you're adding and subtracting integers, I like to think about the number line, especially when you're just learning how to do this. It's the easiest way, I think. You might disagree. So let's say we're going to start at -4 and we're going to add 7. Okay? So you would physically put your finger or your pencil on the -4, and then we're going to add 7. And so because we're using a positive number, we're going to go to the right. So let's go 7 jumps to the right. 1, 2, 3, 4, 5, 6, 7. So that equals 3. So you can kind of see the relationship here. If we would move this guy over and start with him, and then do our -4, we get the same answer, right? Adding and subtracting, it doesn't matter what order you do them in, usually, unless there's any multiplying or brackets or any of that BEDMAS stuff. But if we just had a string of numbers like, right? It doesn't matter what order we do them in. 8 take away 4 is 4. 4 plus 3 is 7, right? But if we did it these two first, 8 and 3, oops, 11. 8 and 3 is 11, minus 4, it's still 7. So it doesn't matter if we switch the order around. So when you're doing integers like we did at the bottom, we took that 7 and moved it to the front. It made a little bit more sense for us to think about 7 take away 4. Okay, we'll try one more example while we have our number line handy. Let's do -7, -2. Okay, so we're going to start at the -7 right here. And then it says for us to jump 2 spaces to the negative. Okay, so negative means we have to go left. 1, 2. Our answer is -9. Okay, so think about those algae tiles that we were just talking about. If our red tiles are negative, and we have 7 of those, and then we're given 2 more, altogether we have 9 of them. And those are negative guys, they're red, so they're negative. There you go. Okay, so here I have a lovely slide with some examples, a number line, and this fantastic graphic that I found on the internet. And then when I went to use it, I realized I really don't like it, so we're not going to talk about it at all. Die, ugly graphic. Okay, good. Glad we got that out of our system. Okay, let's look at the examples. We have -4, -5, and a +7. So if you think about your number line down here, we are starting at -4, and then it wants us to jump 5 to the negative, right? So we're going to the left. 1, 2, 3, 4, 5. So far we're at -9, and then it says to go 7 towards the positive. So we're starting at 9, we're back 1, 2, 3, 4, 5, 6, 7. So our answer is -2. Okay, so this together totaled -9, and then we had to go 7 jumps back towards the positive for -2. Okay, this next one is a little bit trickier because we have 2 negative signs tight together like that. What that means is that, that's why I didn't like this chart, if you have a negative and a negative together, they actually get along so well because they match that the sign is positive. So anytime you see 2 negatives, it's actually positive. 2 negatives right together, that is. So it's the same in English if we said I don't not like cake. Don't and not are both negatives, and they would cancel each other out, and it would actually mean that I do like cake. So the double negative is a positive. And remember I said they get along really well because they match. Anybody who gets along really well and matches is positive. In the next example down here, where we have a positive and a negative, these guys do not match. And so what ends up happening is we go with the negative. When the signs don't match, it's negative. So if we have a negative and a positive, that means we're going to subtract. Okay? I can do a few more examples too when we're done these guys. So let's just try and figure this out. 8 take away negative 9. So because we have two negatives, we are going to add. So I'm changing the signs in there because we know that when we have a double negative, we just add. And 8 plus 9 is 17. Okay, the next example, we are starting at negative 3. So we are here on our number line. And because the signs don't match, we've said it has to be negative. So we started at negative 3 and we are now subtracting 7. So we have to go further negative. 1, 2, 3, 4, 5, 6, 7. We end up at negative 10. Hopefully that makes sense for you. What I would recommend is go on Mathletics and try the adding and subtracting integers unit. They have lots of practice there and you'll get the hang of it. And they also have the videos that show you with the number line. And there's tons of extra practice in the textbooks, and it's just questions just like we just did. So if you're struggling with this, the best way to get better at it is just some practice. Okay, we'll do one more. Negative 1, negative 4. Starting here and jumping. 1, 2, 3, 4. We end up at negative 5. And I hope you're not wondering about this back here where I said, oh, when there's two negatives, it makes a positive. We do have two negatives here, but they're not right tight together because there's a number in between, right? And so we don't have to worry about what the signs are going to do or what the signs are going to change to because they aren't tight together, so they don't need to get along or not get along, right? All right, let's do one more. Since we have time, it's a very short video. Let's do 5 take away negative 4 minus 2. 3 steps on this one. Okay, so we're starting at 5, which is right here. And then we're subtracting a negative 4. What do you notice about this pair right here? They match, that means they get along, and they will now become positive. So 5 plus 4, so we're going to jump 4 towards the positive. Okay, we're at 9 right now. And then we just simply subtract 2. So we're going back the other way, 1, 2. And we end up right there at 7. Hopefully this makes sense to you. If not, come see me or try some examples out of Mathletics or the textbook. Good luck with integers.